Hey everyone, I don't have anything prepared today, so I thought I'd just dive into the code and see where it takes us, if that's okay. Hope that's good with you. So I thought I'd start with my core library. So I'm always talking about why I don't use STL, but obviously if I'm not using STL I must be using something. So I thought I'd show you what I use and how some of it works. So as always, ask questions as we go, and let's see where it takes us. So let's start by getting a list of files. Okay, so there we go. Just make sure you can see that. Cool. It's actually bigger than I thought. We're obviously not going to make it through every one of these files in this stream. There's a lot of stuff. I mean, this isn't a carefully designed library. It's kind of evolved over the years, as a lot of these things do. And there's a lot of stuff in here I don't actually use very often or at all anymore, so probably a lot of it could be cleaned up. So really, I think I'll just pick one or two files and show you the most important stuff. So you can just see here. God, singleton, I don't think I've ever used that class. Threading stuff. Hash maps. So mostly it's containers, you know, like STLs, vector and list, etc. And that's probably what I'll show you first. I think I'll probably just dive into the array class. That's probably the simplest one. But do let me know if any of these jump out to you. Think, oh, what's that? Some of them are very simple and obvious. Could have a look at core.h, but that's not very exciting. So anyway, let's jump into array for now. Bigger. Okay, so talking about STL again, I think every game engine I've worked on has its own container classes, even if some of those just wrap STL. But usually they're custom classes, and I've always had my own classes as well, and rewritten many times over the years. Some engines actually re-implement STL. You know, there's one game company which just rewrote STL and put their own prefix on it, and it was good. It was definitely better than STL. It was better implementation, more optimal. But you know, you're still left with all the problems of STL, which I've talked about in some of the other streams. So I would definitely recommend not doing that. If you're going to write your own container classes, don't think you have to make it look like STL. You know, write your own classes, make them simple, and make it easy for you to work with. Don't try and standardize everything. That's the worst thing you can do. You know, that in STL you can, in theory, swap out a STL vector for a STL list or something like that, and nothing changes because all the interface is the same. Well, how often do you ever want to do that? Not very often. So don't try and make things overly standard. Obviously keep them fairly standard, but don't make things more complicated than they need to be, obviously. So my array class is very simple. This array is just for pod data, so it doesn't call constructors, destructors, or copy constructors when it resizes. Now, look at the resize, so you can see. Resize capacity. So as you can see, it just does a memcpy when it resizes. Now, I've seen some container classes which are for not just pod data, but classes, and they call constructors and destructors and everything. And it's all standard C++, but then in the resize, they'll do a memcpy. Now, you can get away with that in most cases. There are only very few cases where it's not safe to memcpy a class in C++. And it can be done, but I really wouldn't recommend it. I remember fixing a bug in one such engine that did a memcpy on resize for all complex classes. And it was a real edge case bug where basically any class that has a pointer to itself in some way, which is arguably not good practice anyway, but if a class has a pointer to itself, the memcopies are going to fail, obviously, because the pointer won't be pointed to the right place anymore. The pointer will still be pointed to the old array before it was resized. So that's a big no, but that's not often done. But the one place it is done is in weak pointers, like chained weak pointers. So I actually have this kind of class in my codebase. So you have a weak pointer class, and it stores a linked list of other weak pointers. So when the object is deleted, the object will let's say so the base object has a linked list of pointers that point to it, and each weak pointer has a pointer to the next weak pointer here. So when object base is deleted, it can iterate through the list. So in a destructor, you can iterate through and make all the pointers null. Sorry, I'm just sorting out my second monitor. So anyway, that's a case where you might want to store pointers to the class itself, and that will break when you do memcpy in your array resize. So it's not a good idea, in my view, to do that for a normal array class. I mean, it's like I said, it's a very, very small edge case, but when it does happen, it's really horrible. I mean, the case I was talking about where I did find that bug, and it was using some kind of weak pointer. Ideally, we'd have rewritten the code, but that would have required writing an awful lot of code. And the weak pointer was the correct way, in my opinion, to solve the problem we were trying to solve. And it just could not be done because of this memcpy in the resize. And it was a real headache. It was a real subtle, horrible bug to find because it resulted in a memory corruption in the end. And it took me, quite a few days, even a week or so, to track down. It was a really horrible bug because people just weren't expecting it, who were just writing normal C++. It's perfectly valid C++ to do this, and it just wasn't working, but in a really subtle, horrible, memory-creating way. So just from my experience of having to deal with the fallout of it, never do a memcpy in your resize for array of complex classes. So as I've probably shown you before, I have an ObjArray class, which is the same as array, except in the resize, it properly calls the copy constructors, the copy operators. Let's find where it is, resize capacity. So it's almost an identical copy of the class. But as you can see here, it's going through and calling the in-place news for each one, and then a destructor on the old one, which is proper C++, and that's what you should do. But most of my arrays are not arrays of objects, as I think I talked about last stream. I'll make, if the thing I'm putting in an array starts to get complex, I'll just make it an array of pointers, and alloc can free them instead. And in my view, that's a much safer and more optimal way of doing things. So almost always I use this very basic array class, and it's kind of my workhorse for everything. So this is just a little check I put in there for some static asserts to make sure whatever I'm putting in there doesn't have these constructors. So it's just a simple struct or pod type, and it doesn't catch everything. In more modern versions of C++ that I'm using, you can actually do this. I think there's a language keyword where you can tell if it's got a copy constructor, but I'm not using that yet. So this is the best I can do. It catches basic cases, but I never really hit it, to be honest. So the range iterators, as I said before, I use range-based fors now. So this is something I've added recently. And if you've never implemented it, it's very, very simple. Basically, you have a begin-end function, which returns an iterator. And you just pass in this. And an end returns an end iterator. So you pass in this and the count of the array. So it's very simple. It's really nice to set up. And the iterators are just pretty much what you'd expect. Nothing that complex here. So I just have a reference to the actual array we're iterating over and the index, and that's all. So it's really simple. And then obviously a plus operator, which just increments the index. One thing I will say, I always do pre-increments, not post-increments. I can't remember if I mentioned that last time, but there are performance implications for doing a post-increment. So if you don't need to do a post-increment, never do it. Always do pre-increment, which you can read as increment index. And it's just a good little habit to get into if you haven't already. And then obviously the star operator just returns the array, the item at that index. So as you can see, really simple class, and it's definitely worth doing because range-based fors are so much nicer to work with. And again, just a const iterator as well. It does exactly the same thing, just const everywhere, which isn't used often, but occasionally it's needed. So I have some debug info in my array class, which is really important. It does catch bugs. So obviously it has an end guard, so I can know if I go over the array end. I mean, my allocators already have end guards and things like that, but it's just nicer to have it in array class as well, so I know exactly where it's coming from. And I have a locked for iteration, so I'm often using stuff on multiple threads, and if it's a read-only array, obviously anything can do stuff with it. So if I'm iterating over a const array using my const iterator, then multiple threads can do that at the same time. But if I'm iterating over an array with a non-const iterator, that probably means I'm doing something to the items, and it probably shouldn't be done in a multi-threaded way. So I have a bool which just says this is locked for iteration. No other thread should be doing anything with it. and it'll assert if I am. And that's an atomic int here. So that's really good. It catches the odd bug. Just records which thread is currently iterating over it in a non-const way. So again, that's only compiled in if asserts are enabled. So there's no overhead for that at runtime normally. And that's what this assert code macro just defines nothing in release. And that's just the check to say, is this thing we're using in this array safe to be used in it? I showed you earlier. So various constructors, copy constructors as well. Occasionally it's useful to copy an array. I don't often do that. Destructor checks the end marker, clears it off, deletes the memory. So we've got a copy operator, which just does what you'd expect. Reserves, does a memcpy. So there's loads of asserts everywhere, checking it's not locked for iteration. And obviously this class, because it's just dealing with pod data, I can just mem set it to 0, which is nice. I don't have to call all the constructors for everything. And the square bracket operator obviously just does that. This is something that's probably worth mentioning, which I'm not particularly happy about, and I think I will change. Now, I recently wanted to add an allocator to some of my array classes. It's not something I've ever done before, really. I don't tend to do things that way, but occasionally it's useful to be able to give the array class an allocator. So I pass in an allocator, which is templated, and I store a pointer to it and just grab the memory from there when I need it. But the problem with that is it adds an extra pointer to the size of this class. So the size of this class has just got an int, counter capacity, and then a pointer to the array. And I store arrays, especially in 10x, absolutely everywhere. And I have lots and lots of tiny little arrays as well. So if I'm adding another pointer to this class for an allocator, that's going to be, quite a considerable size increase because of the amount of arrays I've got. So I didn't want it to add a pointer if I'm not using it with an allocator. So as you see here, I've got tallocator template, and it defaults to void, which means it doesn't have an allocator. But if I just did it in the simple way, I would still have an allocator pointer in this class, which would increase its size, and I didn't want to do that. So I've done some template trickery, and I don't usually like template trickery, but I decided to give it a go in this case. And the only way, at least that I could find, to stop it actually storing a pointer, because you can't have a struct of 0 size, so I can't just have a struct and then choose to use it or not based on the template. If the allocator is templated to void, I can't just have a struct of 0 size, because that'll, in C++, a 0 size struct will always be a certain size. So the way I found to do it is put all my members in this array members class and then inherit from this base class, which stores the pointer to the allocator. And this, if I remember correctly, uses the template helpers enable if template, which basically says if the template is templated to void, which means if the allocator is templated to void, which means don't use an allocator, then use this class, which doesn't have anything in it. So it's a 0 size class. If it's not void, so enable if here, this means it's not void, it uses this class as a base class. So then that has an allocator pointer and actually a ball. But that's mainly what I wanted, the pointer there. So it's choosing at compile time whether to use this one or the other one as a base class. And the nice thing about, I mean, like I said, you can't have a class of size 0, but if you're inheriting, then you can essentially, because I'm inheriting array members off this. If this goes to the 0 size classes with nothing in, it would just be the size of this array members class without anything in the base. So it turns out the 0 size class, if you see what I mean. And that's the only way I can find to do it, to actually eliminate that pointer. And I believe that's the same way that the standard library does it as well. That's how they choose to do things like this. And it works, it's all fine. You know, like I said, most of the time I don't have allocators, so it's just these members. The occasional time when I do need an allocator, it basically adds a pointer to this class size. So it works, does exactly what I want. It's fairly simple code, except for this template tables enable if, which is horrible, using template trickery. But I think I probably would change it if I had time. I just wouldn't do it this way, because when you look at this in the debugger, you kind of see this members pointer. You want to just open up the array and see the count, capacity, and the pointer to the data, but instead you see this array members class, and then you've got to open that up to see inside what that is. And it's only a minor thing, but like I said before, keeping things simple and easy to debug and work with is so important. And this just adds a tiny little bit of friction to me, and I don't really like it. So what I would probably do if I was doing this again, or if I have time to change it, is just create an entirely new class, copy array.h, call it array, A or something for allocator, and stick an allocator pointer in it and use that when I need it. So that would be duplicating a lot of code, but it's code that I hardly ever touch, and it wouldn't require all this template nonsense. So anyway, it's just I often experiment with my classes and try things out and see what works and what doesn't. So this was just a little experiment. Oh, sorry, I've just seen some comments. Could you repeat about the part about the void parameter on a template? Don't get why it prevents allocations. So let's give you an example. Maybe it would help. So let's so say I've got my allocator, which basically has an alloc and free. So I want to use my allocator, so all the memory that the array uses comes from this allocator. So in the template, I say it's an array of ints, and I'm passing in the template as this, and then I pass in a pointer, or I think actually it's a reference, I can't remember, to the allocator that it's going to use, which is here. And so internally, this array, the members it has is, as I just showed you, and then a pointer to the array. So array has these three members. So that's not part of the code I'm showing you. And I want it to have a pointer also to the allocator it's going to use. And so that's the size of this array class. Now, usually I don't want to use an allocator. And I don't want to pay the cost of having this allocator pointer in my array class all the time, because it's just making it bigger than it needs to be, which does add up if you have thousands of arrays. So what the template stuff does is it removes that when it doesn't have an allocator. So the array class is smaller. So it's not changing any allocations or anything. It's still doing exactly the same amount of allocations. It's just going through the global allocator instead. But what it does do is it makes this array class smaller by the size of one pointer, by the size of that. So it's whether I want this in the class or not. And that's what the templates do. So this is the same as that, just because it defaults to void. So void means the base class I showed you a minute ago will pick the one that doesn't have an allocator pointer in it and make this class smaller. So that's all it is. And it's what STL does internally. It does stuff like that to choose what to do. And it's nice because it makes the class smaller if you're not using an allocator. So hopefully that makes sense. So I'll show you where it does the allocations. Let's go back to the array class itself. So the alloc function. So this is the members class I told you about earlier, which either inherits off something that has an allocator pointer or doesn't have an allocator pointer. And this alloc will, so this is the class that doesn't have an allocator pointer, so it just does a new. So it's just going through the global allocator. If this templated thing did have an allocator, it would go to the other class down here, and the alloc would call the allocator to allocate the memory instead. So that's all it's doing. So it's not changing the way it allocates or frees memory in any way. It's just saying, do I use an allocator or not? And if I don't want to store the pointer to the allocator. So hopefully that makes sense. But like I said, I probably wouldn't do that again if I was writing it again. It's just unnecessarily complex, really. And again, that's the debug info I was telling you about earlier. So I always have this MoveTo function, which I think I talked about a few streams back. And it's really nice because I can explicitly move the contents of this array to another array without doing a memcpy. So it's basically saying, take the data that's in this array and just take it out of this array and put it into another array, which can be really useful, like when you're doing lots of threading and copying an array from one thread to the other. You can just throw away the old array, you don't care about it, and you just want to move the data to a new array class. So it's like a very, or almost instant copy of the array when you don't need the old version anymore. So it just nulls out the old version and sets the pointer to the new one. It's a really nice thing to add to your array class. I would definitely recommend doing that. And that's pretty much it. There's not much more to it, really. The growing is, I actually do ×2 when I grow. So when you're adding to an array, it just increases it by 2, the capacity. I think the best size is probably 1.7. So increase it by 70% rather than 100%. And I probably should change that. I mean, a lot of the time it's better to do it by ×2 because underlying allocators will often have pool sizes of pool sizes of allocations growing in ×2 each time. So you have a pool for 16-byte allocations and a pool for 32-byte allocations, 64-byte allocations, and things like that. So often it can be much better to grow at ×2. Now my underlying allocator, which is called vmem, doesn't do that. It increases in sizes of 16 bytes and up to a certain size, and then it starts increasing slightly bigger above that size. So I'm not actually getting any benefit from doing ×2, so I should probably change that to 1.7. It's just been shown in many studies to be the kind of sweet spot of, because you don't want to grow too big because you're just growing too big unnecessarily, you're having lots of wasted memory. You don't want to go too small because then you're having to keep resizing all the time. So 1.7 is probably the best number to use. So I really should change that at some point. I've just never got around to doing it, because obviously when I do it, I'll want to test it on my codebase just to check that it does A, use up less memory, and B, not make everything that much slower. Because I'm not too worried about memory here, so it might be that ×2 is the best option in my codebase, because I'm not too worried about memory, but I am concerned about speed. So that's just something to keep in mind when you're resizing your array class. So another question, assume you have that allocator parameter for threading purposes, or is there another benefit to it? I'm not sure I understand that. So the allocator parameter is actually for allocating. And the reason I'll do that, what is up with my monitor? And I'll do that is because I want to keep everything, say, contiguous in memory. So for example, when I'm loading the parser of 10x, the C++ parser, and I'm loading up the parser cache, I want everything to be sequential in memory. So I just want to allocate a big chunk of our memory, because it's like, it can be up to a few gig of size. So I just want to allocate a big chunk of memory and then say all my allocations come from that memory, and just increment a pointer to make it bigger. So I used that in this case, and I gave my array classes this allocator, so it would come out of this big pool of memory, which would just be an incrementing pointer. So it wouldn't fragment memory to bits, and it would be very fast and all cache friendly and everything like that. Because I had loads and loads of tiny little arrays. So that's the time when you might want to give an array class its own allocator, mainly just for speed and to reduce fragmentation. So I think that's probably all I've got to say, unless you've got any more questions about the array class. There's nothing, it's so simple. You could probably write this array class in a few hours yourself. I've I don't know how many times I've changed it over the years, but they're only minor modifications. It doesn't have to be complex, and your add function, just call it add. Don't call it pushback or anything crazy like that. And don't call your array class a vector. That's the most crazy thing ever. It's not a vector. It's nothing like a vector. It's got nothing in common with the vector. It's not a vector. It's an array. Call it an array, and call add, not pushback. Okay, just make things easy for yourself. It's if you're writing your own array class, just do it in a sensible way. MoveSwapLast is a really good function to add. Basically, if you don't care about the order of things in an array, so you're treating it more like a set, if you want to remove something from within the array somewhere in the middle or at the beginning, a very fast way to do that is using a function like this, where you take the last element in the array and you overwrite the element you want to remove. And then you just decrease the size of the array by 1. So it means you don't have to do any mem copying or shifting of data. So for example, if you move the first element in the array, you've got to shift everything else down. And that can be expensive, obviously, if it was a big array. But if you don't care about the order of the array and you're treating it like, you can just take the last element, overwrite it with the element you want to remove, and then decrease the size of the array by 1. And it's just a really nice little optimization to do. I often find myself using that. And then you've just got all the operator equals, not equals, contains, reverse the array. Often that's something you want to do. To reverse an array, that's pretty much the most efficient way to do it. You just swap. You start at either end swapping them, and then you get closer to the middle swapping. And it's pretty much the fastest way. Index of I use fairly often actually, just iterates, just a linear iteration through. I mean, for smallish arrays it's pretty fast because it'll be so cache friendly, so it's not actually that expensive as you might think. Trim I hardly ever use actually, but it can be useful. Get a raw pointer, again occasionally I'll use that, but not often. Insert obviously has to do a mem move, but again you wouldn't use that in performance critical code. Adding one array to another, clear, remove range. So I mean, a lot of these functions I just kind of added over the years. I didn't sit down and write this whole big, how big is this class? It's almost 1,000 lines actually, but I didn't sit down and write this all from scratch right at the start. You know, I just added functions as I needed them, and they're so easy to write, these functions. It's kind of fun to do as you're going along. And it's not difficult or not really error prone. So don't be scared about writing your own container classes. That's just one takeaway I'd like to give you from this. It's not as big and scary as some people might think, and it's very easy to get very good performance from your own container classes. And you know exactly what's going on, and they're nice and easy to debug and work with. So yeah, I think that's everything on this array class. I don't know if we've got time to do another class actually. That was pretty much. I guess we should do ObjArray as well, but I don't think there's anything in there that's different. I mean, we could almost diff these, I think, and just see. I think they're fairly similar. I'm going to have to increase the font size, I think. Oh, that's a little bit big. So let's see what's different between array and ObjArray. Apart from the name and white space, not that much so far. Constant range iterator, almost exactly the same. Some tabbing white space stuff, which is annoying. Obviously I don't need to check that it can be safely memcopied, because I'm not memcopying in this ObjArray class. And so comments there, usually I worry a lot about resizing arrays, should try sparing memory pages for them. The one thing I do a lot of is reserving arrays, so you know usually I know roughly what size the array is going to be, so I'll reserve it, and that reduces an awful lot of unnecessary resizing. So that's the main optimization I do for my array classes, is I reserve everywhere that I can, where I know roughly the size it's going to be, and that can help an awful lot. So as you can see here, I'm doing a memcopy in the array class and a for loop copying each one in the ObjArray class, and that's pretty much the only difference. And the zero memory, obviously I can't do that, so I have to call the default constructors to initialize stuff. Placement new instead of copying. So that is actually calling the copy constructor. copy operator, but that's fine. So again, the remove at an index, obviously I can do a mem move on the array and a for loop on the ObjArray class. Apart from that, not much different. And the same for inserting a range. And what's that? Oh, the insert range. Yeah, that's a little bit more complex to insert one array into another array at an index. I don't think I've ever used this function actually. I can't remember. Well, I must have used it somewhere, or I wouldn't have added it. But it's not something I do very often. Adding an array I often add an array to another array, but that's simple. But I would never usually insert an array at an index, so I could probably remove that function. And remove range, obviously, another for loop. Shout if I'm going too fast through this, but I don't think there's much to show you in it really. And a lot of it, like you can see, is actually identical. Just white space changes. Oh, this is an interesting note. In your equals operator, you might think you can just do a memcmp and check the memory, you know, because we're doing mem copies and stuff everywhere else in this class. But you can't actually do that because some structs have padding, and when you've got padding, it's uninitialized memory, and you don't know what that's going to be. So, you know, for example, if you've got a struct with an int, let's say a bool, and that's it, this struct is going to be padded out with just to align it to 16 bytes. And this padding that the compiler will insert is not always initialized. I mean, it depends how you're using your structs, obviously, but there are cases where it won't be initialized. So you can't just do a check memory directly when you're doing this. You have to actually iterate through each element and check if it does equal the other one, because C++ will take care of uninitialized padding. It won't include that in the not equals operator, so that will work. But yeah, you've got to be really, I mean I've been caught out by this bug a number of times, I think, in other code bases. So you can't use memcmp, and that's something you really need to be aware of. So moving on, anything else interesting? Not really. So GGN says one way of getting around that would be to pre-zero everything beforehand, and then memcmp should just work. Yes, exactly. Yeah, it's just really hard because this is a general array class that can be used for anything. It's just really hard to remember to make sure everything is zero, even the padding, because it's not always easy to ensure that, especially when you're working with other libraries and stuff. But yeah, you would never want to disable padding. don't do that. And everything will be padded anyway in the allocator, so you're not actually saving any memory, because in C++ now, 64-bit, everything is aligned to 16 bytes in the allocator. It has to be. So you know, very rarely would you ever actually save memory if you didn't have padding. There are some cases, but yeah, it's not worth doing that usually. So nothing else. I think we're nearly at the end of the class now. I did actually recently go through my ObjArray because it did work a little bit differently, and I recently went through and made it standard to the array, so it works exactly the same way. So I'm fairly certain they are roughly the same now, and that's it. So there we have it, array class and ObjArray. And as I said, they're my kind of workhorses for everything I use all the time, and they have to be as small as possible and as efficient as possible and as simple as possible, so I can work with them in the debugger. And I've also got special, I don't know, should we go into this? No, I should stop in a minute, but I'll quickly show you in the debugger. Why can't I find anything? So you probably know in Visual Studio you can create files that tell the debugger how to interpret things. And I've totally forgotten what mine are called. Natvis, that's the one. It's a little bit too big. So this basically just tells the debugger, the Visual Studio debugger, it's called a natvis file, and you just stick it in your Visual Studio install folder somewhere. I can never remember where. I think I've actually got a batch file that adds it in. Update visualizers. So yeah, it just copies the natvis file into, and the natvis StepFilter file, which is another one, into this folder in Visual Studio. And then when you're debugging, I don't know if this is going to work. Come on, Visual Studio. Is this going to compile? Hope if I added the header. Hey, compiled. So I don't know if you can see this. Everything always goes wrong when I use the window zoom, but let's give it a go anyway, because we're near the end. So test is my array. Obviously I've just added a few members to it, and it basically means you can do that, and it shows you the members of it, rather than if I didn't, it would just show me, it would just show me the count capacity and my array pointer, and I would have to do something like this to see the members of it, which is a bit annoying. But using that natvis file, you tell it what you want to pay here, and I just want to show the count of the counts, so it's easy to see. Even if I don't expand it, I can see it's got a count of 3. And when you expand it, it shows you the members, and that's what these. Stop zooming. That's what these things do. It just says, this is the display string. So this is what it shows you here. And I just say, I want to show count equals, and then in the curly braces, you just put members.count, and that's what it will show you there. And then when I expand it like this, I just want to show the array members of how many there are. And you just do that by saying array items, that's the count, and this is the pointer to the array. And then Visual Studio Debugger works out the rest and shows you the array members in a really nice way. So if you're writing your own array classes, I would definitely recommend, if you're working with Visual Studio, to do this. It just makes things so much nicer and much more easy to work with. And if you ever do want to see the actual class members, you've got the raw view there. And like I said, this is the members class, which I told you about at the beginning, which to do with the allocator and stuff. And this one doesn't have an allocator, so the base class is empty, and it just has the members. And that's what I don't like. I don't particularly like having, if I want to see the raw view, to open up twice. I mean, it's a small thing, but when you're doing it millions of times, it just gets a bit tedious. It'd be nicer if that members thing wasn't there and these were just in the class directly. So at some point I'll probably change that. But for now it's fine. I don't have to look at the members too often. And there's the debug info I was telling you about. So yeah, that's my array class. So someone's saying if C++ is more reasonable, it would be possible to determine if a type had any padding at compile time and safely memcomp it. If it doesn't. Yeah, exactly. It'd be nice if there was a way. It's kind of, a failing of the language really, but it's just one of those little things you've just got to know about and make sure you're not bitten by it. But if you follow the rules in C++, you don't have to worry too much. It's only if you're doing things like memcpy, which you shouldn't really be doing that often in C++ itself. But yeah, it's definitely something to keep in mind. So anyway, that was 2 classes out of my core. Where's my list gone? My list here of all my classes, just see what else we could go through another time. Maybe next time I'll just carry on, find another one that's possibly interesting. Or let me know if you spot something you'd like me to go into. Probably I'd show you the map. Well, all my hash maps I could show you. And then obviously I've got a map, which is a red-black tree. That's quite an interesting one. And linear map is quite nice as well. And linear set. Hybrid array I can show you. So yeah, lots of hashing. I mean, mostly, especially in 10x, I use hashes absolutely everywhere, just for performance reasons. So I don't actually use the map class that often, but sometimes it's useful. Probably talk about debug class. That might be interesting. That's really useful things I have. So anyway, I think I'll leave it there for tonight. I hope you found that useful, and there's a lot more I can go into on this, so we'll probably carry on with this next time. And yeah, do let me know if you have any questions, put them in the comments below, or send me an email, or contact me on Twitter. And yeah, let's try and make C++ a nicer language. So anyway, bye for now, take care, and I'll see you next time.